can, this whole thing is a secondary follicle, including the theca folliculi. And so the entire thing is a secondary follicle. Make sure everyone has it. What is this cell? Primary oocyte. Good. And so it's a primary oocyte. And this white layer, good one, is zona pellucida. And so you can see the zona pellucida being made. The cellular layer is corona radiata. Excellent. And so the next one we will do is the corpus luteum. You can remember that after ovulation, the mature follicle becomes the corpus hemorrhagicum, because there could be some bleeding, and the corpus hemorrhagicum, with the help of LH, will become what? The corpus luteum. And the corpus luteum is the next thing we're going to look at the microscope. A very important structure. And just by looking at this model, I kind of like the look of it, because you have to imagine the corpus luteum was the mature follicle. Remember, the mature follicle had granulosa cells and it had theca folliculi cells. And so what happened is those cells kind of got mixed up a little bit in the corpus hemorrhagicum, and then those cells kind of transformed themselves into the corpus luteum. When you're looking at this picture of the corpus luteum, they often show it looking like it's kind of a collapsed big structure. That's almost the way you want to think about it. If you take this picture of the corpus luteum, can you imagine kind of stretching it out, and it would be a big circular structure with a big space in it. Can you imagine that? If I uncollapsed it and brought it all out. Can people picture that? And so I'm just going to stretch it out, because there's all these folds. If I stretched it out, you would get the idea of the size of the original mature follicle. So what happened is the mature follicle became the corpus hemorrhagicum, and then it kind of collapsed, and the cells of the corpus, or the mature follicle, became the corpus luteum. And so this structure there is the corpus luteum. When it dies, it will become the corpus albicans. But we'll be looking at the corpus luteum in the microscope. And so let me just put on the screen my corpus luteum slide. And so this is, the specimen says corpus luteum. But what is, and you could definitely be asked, what is the organ that we're looking at? Ovary. It is the ovary. Good. So you don't want to forget that the corpus luteum lives within the ovary. So we're looking at the ovary. The outer edge would be the germinal epithelium. And so this is all ovary. And then I can see right here this huge structure that looks kind of fluffy. Looks a little bit like cotton candy. That's the way I kind of think of it. Is the corpus luteum. And so that's a good place right there to see the corpus luteum. And it looks kind of fluffy. It looks a little bit like cotton candy. It is a hard one to draw. So this is, you can see my picture, kind of hard to draw. So but this was trying to draw that. And so it's kind of hard to draw it. But that is the corpus luteum. Let me go back to my view here. Notice then the model, and this is, they try to show the model pretty accurately, where the model is showing these little folds. These folds are actually, you can see right here, a little fold right here. And you can see the fold right there. And the reason is because this huge mature follicle basically collapsed. When it collapsed, you would have these folds. And so, but this is the corpus luteum slide. There are two main cells within it. There are the darker cells called the theca lutein cells. They're called theca lutein cells because these cells were the theca folliculi. You have the granulosa lutein cells because they were the granulosa cells. And so when I'm looking here, the most abundant cell, all of the light pink cells here, all of these light pink cells here, are the granulosa lutein cells. They used to be granulosa cells. But then after ovulation, it became the corpus luteum, and now you have the granulosa lutein cells. These darker ones here used to be the theca folliculi, but now they are the theca lutein cells. And so when you are looking at this, you can kind of imagine these cells were on the outside of the follicle, and now it's collapsed, and you have these darker cells, and you can kind of see the theca lutein cells would be where those folds are. And so questions you could be asked, if you were given this, you'd want to know the specimen is the corpus luteum. That's what it says in the slide. But the organ you already mentioned is the ovary. And so you definitely want to recognize, okay, we're looking at the ovary. And when you look at this particular slide, you'll see how big the corpus luteum is. And it's a more demonstrative of how big that mature follicle was too. That's also why I don't like doing the mature follicle on the prior slide, because mature follicle is gigantic. And you can appreciate that with the corpus luteum. And so what is this one kept alive by? So we're looking at the corpus luteum. Two hormones keep this alive. They are LH and HCG. So remember that HCG is structurally and functionally very similar to LH. One other time that you can see that, remember in when a boy is in embryo, mom's HCG will cause the boy to make testosterone. Do you remember that? What hormone, when an adult male, causes the testis to produce testosterone? LH. So during adulthood, LH stimulates the testis to make testosterone. During embryohood, HCG stimulates the testis to make testosterone. And so you should see that correlation with the male. These two are very similar structurally and functionally. And so they both are keeping the corpus luteum alive. Corpus luteum maintains the blank by secreting two hormones. It maintains what?
The
Stratum functionalis. So stratum functionalis is maintained by the corpus luteum because the corpus luteum is secreting estrogen and progesterone. Another important thing to remember, that LH is keeping the corpus luteum alive, but when LH goes down, corpus luteum dies, therefore it can't secrete estrogen and progesterone, and you get the stratum functionalis dying. And so corpus luteum, very important. With a model or with a microscope, definitely could be asked kind of questions related to the female reproductive cycle, how the hormones are related to it. And so so that is the corpus luteum. So you'd want to know the whole. So the other question: what is the entire structure filling the field of view? Or the specific structure filling the entire field of view? Corpus luteum. That's a more likely way I'll ask you corpus luteum rather than the specimen, because the specimen you could say, well, it's the ovary also. And so I like to say, what is the specific structure filling the entire field of view? All of that is corpus luteum. And then you could be asked questions related to the hormones. You could be asked, the cell here or the cells there. And together they're making those 4 ovarian hormones. And same idea, kind of the theca folliculi cells, or the theca lutein cells here are making androgens. Those androgens go over to the granulosa lutein cells and make estrogen out of them. Same kind of way that the estrogen was made in the follicles before. Any questions with that?